Good morning, everybody. Thank you for joining us for this edition of our Bick Gardner 1-hour web seminar. I'm coming to you from Bick Gardner's North American headquarters in lovely Columbia, Maryland. And today's topic is gloss in theory and in practice. So hopefully you've all managed to connect to our audio or to the WebEx audio. If you are currently hearing my voice, congratulations, you have done so. For everybody else, hopefully this slide will be helpful. We'll leave it up for just a minute. Moving on. I am your speaker today. My name is Corey Cohen, Application Specialist with Bick Gardner USA for over 10 years now, and I specialize in customer education and technical training. Some general information about today's web seminar. You have all been automatically muted, so you can scream whatever obscenities you like at me. No one can hear you. If I have not answered any of your questions by the end of today's presentation, you can feel free to enter them into the chat box, and we will have some time to answer some questions following the presentation. And yes, a PDF version of this presentation will be sent to all attendees in the days following today's web seminar. So let's get started. Gloss in theory and in practice. Today's agenda includes total appearance, measurement geometries for gloss, when to measure with 2 or 3 angles, influence of material and surface structure on gloss measurement, and limitations of gloss measurement. So surface quality has to do with things like gloss, haze, distinctness of image, color, effect, orange peel. So there are a couple different ways that we can evaluate a surface. One is to focus on the reflected image, and in this case, we're evaluating the image-forming qualities of the surface. So we want to see, when light bounces off the surface, how crisp and clear is that reflected image going to be, and that has to do with things like gloss, reflection haze, and DOI, or distinctness of image. Another way to look at a surface is to evaluate the surface itself. And this is evaluating the waviness in the surface, or a phenomenon that we refer to as orange peel. And this is done with our wave scan instrument, which is another web seminar. We won't be going over that today. But that includes things like short wave and long wave, all the different structure sizes in the surface that can affect how we see the surface or how we see an image reflected off of the surface. So, gloss. So for a glossy surface, how is gloss perceived? So for a highly polished surface, a very smooth surface, if you have direct illumination on the surface, which you see here, so we have a light source shining light directly on the surface, and because this is a highly polished surface, a lot of that light is going to reflect off at the opposite angle, or what we refer to as the specular angle. And so an observer positioned at that specular angle is going to see a nice, crisp, clear, reflected image of that light source. Now, if we're instead talking about a rough surface, which would be a low gloss surface, this means that when you shine light on the surface, when you illuminate it directly, less of that light is going to reflect off at the specular angle, that opposite angle, and more of it is going to be diffused. It's going to reflect off at all different angles. And this is going to cause the observer positioned at that specular angle to see a fuzzier, less distinct reflected image of that light source. So when we build a gloss meter, we have a light source at a defined angle, and because we're measuring gloss, and gloss is measured at the specular angle, that detector, the light detector, is placed at the specular angle, or the opposite angle to the light source. So gloss is simply a measure of how much light is picked up by that detector at that specular angle relative to certain standards. So when it comes to gloss measurement, there are three standard defined angles of illumination, or defined geometries. The first one, and the most commonly used one, is the 60-degree measurement angle. The next one is the 20-degree angle. This is for high gloss. And then we have the 85-degree angle for low gloss. So here you can see the convention we use for recommending when to use which measurement geometry. So 60-degree, we consider that the optimal geometry for the semi-gloss range, which is what we consider to be anything that measures between about 10 and 70 gloss units. If you measure your surface with a 60-degree gloss meter and you get between 10 and 70 gloss units, we would recommend sticking with the 60-degree meter. Now, if you measure your surface with that 60-degree meter and you get greater than 70 gloss units, we recommend switching to the 20-degree geometry, the specialist for high gloss surfaces. And then if you get less than 10 gloss units with a 60-degree meter, we would recommend using the 85-degree geometry for low gloss surfaces. And so this graph illustrates why we have different gloss geometries and why we recommend different geometries for different ranges. So on the x-axis, the horizontal axis, we have 13 gloss panels, and these gloss panels increase in gloss in equal steps. So the visual difference from one gloss panel to the next are equal all the way up. So the visual difference between, say, the 2 and the 3 gloss panel are the same as the visual difference between the 10 and the 11, or the 11 and the 12. So equal visual steps increasing in gloss on the horizontal axis. And on the vertical axis, we have measured gloss in gloss units. So we have 3 measurement curves here, a measurement curve for each geometry telling us how many gloss units is measured by each geometry for each of these 13 gloss panels. So these measurement curves tell us why we use certain geometries for certain gloss ranges. So, for example, starting with the 60-degree geometry, we see that at the lower gloss panels, that measurement curve starts off kind of flat, kind of horizontal, not very steep, not very even or linear. And then once we get into the semi-gloss range, once we get above 10 gloss units, that curve does become fairly steep. It becomes much more linear. And so this is the optimal range for the 60-degree gloss geometry. Similarly, in the low gloss range, the 85-degree geometry, that's where that measurement curve is nice and steep and even, and it flattens out and becomes less linear as it gets into higher gloss levels. And for the 20, that's the specialist for high gloss. So in the low gloss and the semi-gloss range, the 20-degree curve is, again, not very steep, not very linear. But once we get into that high gloss range, we get a nice, steep, even slope. So to tell us why this is important, I'm just going to use an example. So let's say we want to measure the gloss difference between panels, say, 2 and 3. So if we measure that with our 60-degree geometry, we're seeing a gloss difference of only maybe 1 or 2 gloss units there. But if we measure the difference between the 7 and the 8 panel, now we're seeing maybe a 16 or 17 gloss unit difference. So remember, the visual difference between the 2 and the 3 is the same as the visual difference between the 7 and the 8. But when we measure the difference with that 60-degree geometry, we're getting a much larger measured difference in that semi-gloss range than we are in the low gloss range. So this is why the 60 degree is optimal in the semi-gloss range. Similarly, if we were to measure the difference between panels 2 and 3 with the 85 degree geometry, we would get a difference of maybe 13 or 14 gloss units, whereas the difference between the 7 and the 8 panel as measured with the 85 degree geometry is only something like 4 or 5 gloss units. So again, 85 degrees is optimal in the low gloss range, 60 in the semi-gloss, and 20 degree in the high gloss range. So if you want to measure all three, which is often recommended, we have a unit that has all three measurement geometries in one, our micro tri-gloss instrument. So this is in compliance with international standards such as ASTM and ISO. And with this instrument, you can simultaneously measure 1, 2, or 3 angles and display them at the same time on the screen. So here's an example of a weathering test. So we have 2 panels with different coating systems that are being weathered over several hundred hours. And at various points along this, this weathering test, each of these panels is being measured by a gloss meter. So here we have the measurement curves as measured with the 60 degree geometry. And we can see here that both panels are measuring at about the same level until about 200 hours. It's only when it gets up to about 250 hours that we're seeing any significant difference in gloss measurement between these 2 panels. But if we switch to the 20 degree geometry, this blue and this pink curve, we can see that there actually are significant differences between panel A and panel B well before we hit that 250 hours. But this is not measurable. This difference isn't really measurable with the 60 degree geometry. We need the 20 degree geometry for high gloss in order to see these differences. And if we think back to those, the convention that we use for when to use which geometry, we see that these panels, if we measure them with the 60 degree, they measure at about 90 gloss units to start with, and that's in that range that we would typically recommend using that high gloss meter, the 20 degree geometry. But we can see that as time goes on, these measurements do dip down below, or at least one of the panels dips below 70 gloss units as measured with the 60 degree geometry. So this is one case in which you might actually want to take measurements with multiple geometries, with the 20 and the 60, which is what makes that tri-gloss instrument with all 3 geometries so useful. So you might be wondering what exactly is a gloss unit. It's a relative unit for comparative purposes, and so this was established way back when gloss meters were first being developed. And they took a black glass standard, a highly polished piece of black glass of a particular refractive index, 1.567, and declared that this polished black glass represents 100 gloss units. So all other gloss units, all other gloss measurements are relative to this initial piece of black glass that was used during development of these gloss meters. So some other benefits of our micro gloss instruments. One of the great things about this instrument is that it does an auto diagnosis in the holder. So every meter comes with this gray holder that has a black glass standard set inside it. And so when the meter is in the holder and you turn it on, it automatically takes a measurement of that gloss standard and makes sure that it's measuring accurately. If it's not measuring the black glass and getting the value it knows it should be getting, it's going to ask you either to clean the standard or to calibrate the instrument. So this way you know that every time you turn on the meter, you're going to get accurate gloss measurements. So in addition to having all 3 angles available in one instrument, these meters are also capable of measuring a full range of surfaces from matte to mirror-like surfaces. And when we say mirror-like, what we really mean is very, very shiny metals, which measure at very, very high gloss values up to 2,000 gloss units. And so our meters have this expanded measurement range that allows you to measure full range of surfaces. So when we talk about paint or plastic, typically any paint or plastic, there's going to be a significant amount of absorption going on when the light hits those materials. And so those materials typically max out at about 100 gloss units. You're not going to measure a paint or a plastic, at least ones without any sort of special metallic pigments or anything, and get it much more than 100 gloss units. But when it comes to metals, metals have near total reflection of the light. So whereas with paints and plastics, you're getting a lot of absorption of the light, with metals, you're getting none of that. All of the light is being reflected off the surface, and so this is why metals can measure at hundreds or even thousands of gloss units when other materials can't measure that high. So when it comes to metals, typically, or often I should say, metals are, gloss levels for metals are specified in percent reflectance rather than gloss units. And it's a very easy conversion from gloss units to percent reflectance. It's simply the measurement in gloss units as a percentage of the full scale. So for example, the 20-degree geometry, the full scale is up to 2,000 gloss units. And so if you measure a surface and get 100 gloss units, that is equal to 5% reflectance. Similarly, for the 60-degree geometry, that goes up to 1,000 gloss units, and so a measurement of 100 gloss units with a 60-degree geometry would equate to 10% reflectance. And for the 85-degree geometry, remember this is for low gloss, so this only goes up to 160 gloss units. And so a measurement of 100 gloss units at this angle would equate to a percent reflectance of somewhere around 65%. The microgloss has unsurpassed technical performance, excellent repeatability and reproducibility, both short and long term. So the repeatability of our gloss meters in the 0 to 99 gloss unit range is 0.2 gloss units, and this just means when you take repeated measurements with the same meter, you can expect those readings. When you repeatedly measure the same sample with 1 meter, you can expect those readings to agree with each other to within 0.2 gloss units in that 0 to 99 gloss unit range, and to within 0.2% of the measured value at greater than 100 gloss units. And for the inter-instrument agreement, which is also referred to as the reproducibility, this is how well you can expect different gloss meters of the same make and model to agree with each other when measuring the same sample. That inter-instrument agreement in the 0 to 99 gloss unit range is half a gloss unit, and in the greater than 100 gloss unit range, it is 0.5% of the measured value. Now we also have the S family of gloss meters for certain applications, and this provides better precision and less measurement uncertainty in the low gloss range. So the reason for this, now when you get into the very low gloss range, this is of course when we recommend switching to the 85-degree geometry. However, because the 60-degree geometry was the first one, it's the most widely used one, there are a lot of industries that have standardized on the 60-degree geometry even in the low gloss range. And so it becomes very important to decrease the measurement uncertainty in that range, because remember what we saw before, visual gloss differences are going to correspond with smaller measured gloss differences in that low gloss range for the 60-degree geometry. So when you get smaller measured differences, what that means is that you have to have tighter tolerances. tighter numerical tolerances. And so that means that the measurement uncertainty is going to represent a larger portion of that measurement tolerance. And we don't want that. So we designed this meter to have better precision, better measurement uncertainty, which every instrument has measurement uncertainty. It's an inherent part of any measurement tool. But this instrument, the S family of microgloss meters, has better precision, better repeatability, and reproducibility, specifically in that low gloss range for when you have a specification to measure low gloss materials with a 60-degree geometry. So back to our unsurpassed technical performance. This time we're talking about temperature stability. So we have a patented calibration process during production of these meters where the meters are stepped through a range of temperatures to ensure that the readings are going to be stable. These meters have great temperature stability between 10 and 40 degrees Celsius, which is about 50 to 104 degrees Fahrenheit. So it's a fairly wide operating range of temperatures where you can expect to get very, very similar values, very good temperature stability in that range. So you can have swings of as much as 50 degrees Fahrenheit and expect your readings of the same material to agree with each other to within 1 gloss unit. And we have also several gloss meters for specific applications. So we have a micro trigloss meter, the meter with 3 measurement geometries in one. That also comes with a built-in film thickness gauge that is capable of measuring over steel or aluminum, that is ferrous or non-ferrous substrates. So you can get your 3-angle gloss measurement and your film thickness measurement in one instrument with one button push. We also have a couple of specialty geometries. We have the 45-degree geometry, which is great for plastic film, and ceramic. We also have the 75-degree geometry, which is good for paper, paperboard, and structured plastic, such as vinyl siding. Microgloss also comes with certain smart functions, such as full statistics. You can measure in averaging mode and get the statistics like min, max, range, and standard deviation. You can save those measurements in the memory and name them. There is a difference mode with pass-fail indication, so you can program your gloss specification and your tolerances into the meter and take a measurement, and it will automatically tell you whether it is a pass or a fail. It also has a continuous mode where it will measure continuously at a selected interval as small as every second. And this is great for when you need to take measurements on very large surface areas. You can set it for continuous mode and just sort of move the meter across the surface and take a bunch of measurements without having to press the button every time, and then get statistics on those measurements. Again, the average, min, max, standard deviation, things like that. Every gloss meter also comes with our Smart Chart software, and that allows you to choose between 2 different modules. You can choose either SmartLab for gloss. This allows you to either measure offline and save your data in the instrument and then download it later, or you can measure in online mode. You can also produce professional-looking QC reports, which I will do a demonstration of in just a bit. It has a standard management function where you can input standards and pass-fail limits to load onto the meter. And you can manage your gloss data in projects to show production stability. The other side of that is our Smart Process module for gloss meters. And this is ideal for products with multiple measurement positions such as if you need to measure the gloss of a car on a bunch of different panels. So you can set up organizers for menu-guided test sequences and sample ID. So you can set this all up in the software, load it onto the meter, and it will tell you exactly how to measure, how many measurements to take, what order to measure your panels in, all that stuff. And the data is saved in SQL databases with flexible data analysis and scorecard and trend reports. So now for our demonstration of the SmartLab gloss module, allow me to switch to our SmartChart software, and I will enter SmartLab for the microgloss. Now you can see here listed is all of the projects I currently have on this computer. And so all of these projects already have data in them. I could open up any one of them to view my data or to add more data to it. But instead, I'm going to open up a new project. And the first thing I'm going to do when I open my new project is I'm going to add a standard. And it gives you three options when adding a standard. If I have a standard in my microgloss meter that I want to download, I could do that. If I have a standard saved in my standard management database, I could load one from there. Instead, I'm going to create a new standard. And so this gives me the options for my standards. So first of all, I know I want to average 3 samples per, 3 readings per sample. So I'm going to put this on 3. Now I have currently a micro trigloss meter with film thickness. So if I wanted to, I can measure at 20, 60, and 85. But let's say my specification is only for 60. That's all I care about right now. So I'll add that to my standard. And I also want to measure thickness. So I've added those scales, and now if I want to, I can also add tolerances here. So suppose my specification is that the gloss measurement at 60 degrees of my product should be greater than, say, 80 gloss units. So I can add a field here, enter 80, and now I'm setting it so that when I measure my samples, if I get greater than 80 gloss units, it will tell me it's a pass. If I get less than 80 gloss units, it will tell me it's a fail. I can even add additional fields here, sort of a warning field, and I can set this at, say, 85. So this tells me that if my gloss measurement is above 85, it's well within the tolerance, and it's a green. If it's between 80 and 85, it's still within tolerance, but it's getting close to being out of tolerance. So that's something maybe to look for, to look at the production process. And of course, again, anything less than 80 gloss units would be a fail. Now down here, I can select my scale for gloss, either in gloss units or percent reflectance. I'll leave it in gloss units. And I can select my scale for the film thickness, either in microns or mils. So I will leave that on microns and click apply. And now it's time to take my measurements in online mode. So now that I've got my standard, I've established my standard and the settings for my standard, I can now add a test series. So again, I get 3 options for adding a test series. I can download data from the instrument if I have any stored in there. I can load data from a database if I've stored data in a database. Or I can measure a test series in online mode, which is what I will do right now. So once I click that, it will allow me to name my test series if I want, or I can just leave it as default. So I'll name it whatever I like. Now you can see here that the above here, I see 3 little blue dots, and that's because I set it for an average of 3 measurements per sample. So I'm going to plug in my gloss meter. It's recognized it. Now I can take my measurements. So I'll take my sample and place my gloss meter on top. Now again, I can rename the sample up here. I'll just leave it as sample 1, and I'll place my gloss meter on top of the sample. And now I can either initiate the measurement by pressing the button on the gloss meter itself, or by pressing the measure button on the screen, which I'll do now. So it's going to take a few seconds for the measurement, and the reason for that is because currently I have the film thickness measurement set in combination mode. And what that means is, so this meter, the built-in film thickness gauge, can measure on both ferrous and non-ferrous surfaces. And so if you know which substrate you're using, you can set it for ferrous or for non-ferrous, and the measurements will be a little bit quicker. But since I have it on combination mode right now, it is going to automatically detect which substrate it is and switch to the correct mode, and that takes just a few seconds. So I've got my 3 measurements for sample 1, so I can move to the next sample and go ahead and measure sample 2. Excellent. So I've got my 3 readings for sample 2. Now, if I wanted to measure more samples, I could, of course, click Measure Next Sample, but I only have these 2 samples to measure right now, so I'll click End Test Series. And so here we have our data table with our measured data, and then below that we have some graphs, some line graphs of the measurements with our gloss and film thickness measurements. And you can see in the data table, this measurement, the gloss measurement of sample 1 is showing up highlighted in red with the red dot symbol in the status field. And that's indicating that based on the tolerances, the specification and the tolerances I've set for the standard, this panel is actually a fail. So the gloss is lower than it should be, whereas with sample 2, the gloss is nice and high, well above the 80 gloss unit threshold, and so that status is a green symbol. And if I look at the film thickness, I can see maybe why the gloss is a bit off for sample 1, because the film thickness isn't as high as it is for sample 2, 83.4 microns for the sample 1, which is a fail in gloss, versus 102.3 microns, which passes for the gloss measurement. And so maybe if sample 1 had sufficient film thickness, maybe the leveling, the flowability will be better for my coating, and the gloss will be higher. So now I've got my measurements. Suppose I want to share this with somebody. So I have several options for doing this. One thing I can do is I can save the project. And that saves the file, it saves the project as a file on my computer, which can be opened with SmartChart. So I could actually take that file and email it to somebody, and if they have SmartChart installed on their computer, they could then open up that file and see the gloss measurements in the same way that I'm seeing them right now. Another option for sharing the data is to export it. And you have the option of exporting to either Excel or a CSV file, which can be useful if you want to import the data into some other software. And I can also create reports using the print function. So I clicked print, and now it's going to produce a report for me. Here we go. I have a title page, I have my data table, and then I have my graphs. And now these reports are highly customizable. If I don't want one of these options, I can deselect them here. I could change the title. I could enter comments here. And when I click reload, those things will be reflected in my report. And there's actually additional customization you can do by clicking the configuration button. So this is very highly customizable. You can select various components to add or remove from the report. There are things you can do, like on the title page, you might have noticed that there was this BIC symbol. Maybe you don't want the BIC symbol on your gloss measurement report. So you can actually change that. All you need is a picture file, which I have here. I have my own paint company logo, Corey's Super Awesome Paint Company. And so when I save this and exit out, again, the report is going to reload, and it's going to load my logo this time. So very, very customizable. You can do whatever you want, set up these reports however you want. You can also save any customization as a template. So once you have it the way you want it, you don't have to set it up every time you want to produce a report. You just save a template and then select the appropriate template, and it automatically formats the report in exactly the way you want it. Now, once I've got my report the way I want it, I can share it with somebody else, either by printing a physical copy, or I can download or save the report as a PDF file to share via email or USB stick or what have you. So that concludes our brief SmartLab demo today, and I will return to the presentation. I have just a few more slides to go over. So as with any type of measurement, particularly with optical measurements such as gloss measurements, you want to establish standard procedures, standard practices for your measurement. For example, one thing you need to establish is the gloss geometry for measuring your gloss. Anytime there is a specification for gloss, you need to establish which gloss geometry that specification is for, because of course different gloss geometries are going to give you different measured values. So it's important to use the same gloss geometry every time. For large samples, or even for samples that aren't so large, but if you're dealing with any sort of painted panel, anything like that, you're often going to encounter some variation across the surface. So it's often recommended to do averaging when measuring certain materials. For example, here, an average of 5. We often recommend measuring in this, what we call the 5 on the dice pattern, where you have one measurement in the center and then a measurement in each corner for a total of 5 measurements. And another important thing to establish is the measurement direction. This is important because when you're dealing particularly with textured surfaces or any sort of machine striations or anything like that, the direction of measurement can matter. It can influence the gloss readings you're going to get. So you want to establish a standard direction for taking your gloss readings. And even if it's just a painted panel where it doesn't look like there's any directionality to it, you can still get some variation when you turn the meter in different orientations. So it's good to standardize on a particular orientation when measuring gloss. So another specialty application is measuring gloss on transparent or translucent samples. And as we can see here, part of the difficulty when measuring transparent samples is that there's going to be some interreflection of the light within the material itself. And so some of that light will be lost in the material and will not make its way to the detector. Another thing is that when you have transparent samples, whatever is behind the sample or backing the sample can influence your gloss measurements. So this is why we recommend standardizing the backing of the sample when taking gloss measurements. So again, you always want to compare apples to apples. You always want to be measuring in the same way. So you want a consistent backing for measuring your transparent samples over. And for this, we generally recommend a black matte background. And we recommend that because black matte materials are going to have the least reflection. So a backing like this will have the least influence on your gloss measurements. And another thing to consider is the sample thickness. Because of those interreflections where some of that light is going to be lost, as long as you're consistent, as long as you have a consistent sample thickness, the more or less the same amount of light will be lost, and you can get very good comparative measurements on different samples if they have the same thickness. So this is another thing that you want to standardize on. You really only want to compare measurements of transparent samples with a similar thickness. Sometimes there is a desire to measure gloss on very small parts. There have been a number of major consumer electronics producers who in recent years have started measuring gloss on their parts on these very small areas. And for that, we developed the MicroGloss XS, which is our small aperture gloss meter. So this comes in a 60-degree geometry. It's still according to international standards, so it still conforms to ASTM, ISO, all that. And this one has a spot size of only 2 by 4 millimeters, which makes it great for very small parts and small components. Now, this version also comes in an S model. Remember, that is the model that has better precision and less measurement uncertainty in that low gloss range when measuring with the 60-degree geometry. We also have a new robotic version of the MicroGloss. It has a fixture for mounting on an automated measuring system like an XY table. And the contact of the surface can sometimes be required depending on the gloss level and measurement area. Another thing to consider is when measuring gloss on curved surfaces. Ideally, gloss is always measured on perfectly flat surfaces, but of course, there is often a need to measure on curved surfaces. The thing to know, though, is that because of the thickness of the light beam, the width of the light beam, when that light beam hits a curved surface, you're going to get some of that light bouncing away from the detector, even when this has nothing to do with the gloss level. It's just the curvature of the surface that's going to deflect that light away. So even if these two surfaces, if a flat surface and a curved surface have the same visual gloss, you will get different gloss readings. Typically, a curved surface all things being equal, will measure at a lower gloss level than a flat surface because of this. So this is another situation where you really only want to compare gloss measurements of curved surfaces with other similarly curved surfaces. We also have a few accessories for measuring materials in their liquid form, such as wet drawdowns and also powdery and pasty products. So we have a wet drawdown template where you can, if you have a need to measure your material in a wet form, you can do a drawdown of it and then place this template on top. And this is perfectly fitted for our micro gloss meters, so you can set the gloss meter on the template. The template will hold the gloss meter separate from the sample, very close to it, but with some separation so that you don't contaminate the aperture with your wet material and you can still get a good gloss measurement. We also have for powdery or pasty products, this is called the round dish sample holder. So you can put your powdery or pasty product in one of these small metal dishes and flatten out the top. You then place that into this sample holder, which again has its own template that you set on top. And then you set your gloss meter on top of that template. And again, it will keep the gloss meter just slightly separate from the pasty or powdery surface. So again, you can get your gloss measurement without risking contaminating the aperture. And that does it for our technical presentation today. We want you to know that you can call on any of us at any time. This is our technical service team with Vic Gardner, including those of us here in the U.S., as well as our colleagues over at our German headquarters. And you can see all of our contact info listed here. Feel free to give us a call or shoot us an email. We would love to discuss your application with you personally. We do have a new website at byk-instruments.com. Check it out. We also have a bunch of videos on YouTube, so if you want to see our instruments in action, how they're actually used, you can check that out at youtube.com/user/BIC-video. We are constantly updating our website with new web seminars that are coming up. So if you're on our mailing list, you will automatically get notification of any upcoming web seminars. But you can also go to our website, again, byk-instruments.com, and check out our web seminar schedule there. And when we are free to travel again, we do like to perform on-site seminars for you. So if you have a desire to have us come to your location, we can customize a presentation just for you. You can learn about whatever topics and instruments that you want to learn about. We can bring our instruments with us so you can try them out, see how they feel and look and all that stuff. And finally, we would love it if you would come visit us, of course, again, when we are free to travel once again. So my colleagues at our German headquarters would love to host you at our main production facility in Geretsried, Germany, which you can see at the top left there. They can show you around the facility. And also, if you happen to be in Germany, I highly recommend trying out the beer there. Turns out it's delicious. You can also visit us at our North American headquarters, which you can see at the bottom left. This is located in Columbia, Maryland, right between Baltimore and Washington, D.C. So plenty to do and see around here. And of course, we love our Maryland blue crabs here, particularly our crab cakes. And of course, every restaurant in Maryland claims to make the best crab cakes, and they are all correct. So try them out while you're here. So there we go. And I will now turn to the chat box to answer some of your questions. Again, if you have any questions that I have not managed to answer during this presentation, feel free to enter them there, and I will try to get to as many as possible. What are the dangers of measuring embossed surfaces greater than 10 gloss units with the 85-degree angle? So it's partly that, remember from those measurement curves, we saw that any visual differences you see, the 85-degree geometry is going to measure smaller differences in that range than the 60-degree geometry would. But in addition to that, because of how shallow the 85-degree measurement angle is, the light source is almost parallel to the surface. It's a very, very shallow angle. Some of that light, if you're talking about an embossed surface or a textured surface, some of that light can get lost and reflect away due to those structures in the surface, which has nothing to do with the gloss level. It's just the structure. So you might get lower than normal gloss measurements if you're dealing with embossed or textured surfaces. So it really is better to use a steeper angle when dealing with structured surfaces. Is there a required or recommended time frame for how long the black part in the gray holder should last or be replaced? I believe you're referring to that black glass standard. Properly cared for, as long as you don't scratch it or mishandle it, it should last for the life of the instrument, which, if you've ever owned one of our instruments, is typically a very, very long time. So just make sure that you keep the gloss meter in the holder when not in use to protect both the instrument aperture and optics as well as that gloss standard, and it should last for the life of the instrument. In what gloss range would 45 degree be preferred for plastic films? Unfortunately, I don't have a defined convention as I do for the 3 standard gloss angles, but the 45 degree was chosen because it's sort of part way between the 20 and the 60 degree, the semi-gloss, between the semi and high gloss. So if it measures in that sort of high semi-gloss range, that's where that's optimal. Really, it just comes down to whether a meter is able to differentiate between visually different samples. So really the best thing to do is do some experiments, take some samples that are visually different, measure it with a meter and see what gloss differences you get. And we are always happy to measure samples for you. If you're considering a meter but you don't know if it's going to work for your application, we encourage you to send us samples that we can measure and report the results to you and discuss them to make sure before you purchase a meter that it is going to work for you. So again, all of our contact info is in this presentation, which you will all receive. So if you are unsure what exactly you need or if one of our instruments will work for you, please reach out and consider sending us some samples for measurement. Ana Garcia, I'm sorry, I'm afraid I don't understand what it is you're asking there. If you could try to clarify, hopefully I can answer your question. Cesar asks, how is the size of the piece that can measure? How big is the size? So I don't know them off the top of my head. It's something like 2 by, for all 3 geometries, it would be 2 by maybe 3 centimeters. It is listed in our catalog and on our website. So if you look up our meters on our website, the measurement spot size will be listed there, and that will tell you the minimum sample size. And of course, we have our excess meter, our small aperture meter. If you have very small parts that you need to measure, you can use that small aperture meter for that. Where is the U.S. office located? We're in, again, Columbia, Maryland. We're on the East Coast of the United States. Okay, so most of my customers, automotive interiors, have low gloss parts, but always define their gloss targets and tolerances measured at 60 degrees. I'm talking about 1.5 gloss units plus or minus 0.2 gloss units, very, very tight tolerance. For example, would you recommend to record 60 and 85 degree gloss data for better quality control? Yes, that is a good idea. He does mention that he's using an S family gloss meter, so that's great. You would definitely need that for such a tight tolerance in that low gloss range. And yes, I would recommend measuring at both those gloss angles because of course you would need to report the gloss values in the specified angle at 60 degrees, but for internal use to improve your production processes and for QC purposes, you could certainly use that 85 degree gloss data. Is there any influence for outside measurement? I believe what you're referring to is the influence of ambient light, and the answer is no. The gloss meter uses closed optics, so it shuts out any outside light, and so you're not going to get any influence of whether you're measuring inside or outside. How is the instrument calibrated? So there are two types of calibrations. There's a user calibration, which is done, of course, by the user, by you guys, using your gloss meters in the field, and that is done on the black glass standard that is in the holder. So not only is it a checking standard to make sure that your meter is performing and measuring correctly, but it is a calibration standard as well. And there is also a service calibration that we do here in our lab, our service lab. And again, we do on-site service once, again, we are able to travel. We can bring all of our gloss standards to you. And so those service calibrations are done on a series of, don't hold me to this, I believe it's 26 different gloss standards, and those are certified by a German organization called BAM, which is very well known, very well respected institution for certifying gloss. So you can do your self-calibration or your service calibration. And of course, our service calibration comes with an ISO 17025 certificate. Cesar clarified, can we do field measurement? Yes, of course. It is a handheld meter, very small, very light, easy to carry around. So as mentioned, you can measure in online mode, as you saw me do during the demonstration, but you can also store your readings in the meter itself. So if you're not able to measure while connected to a computer, you can take it out to the field, take your measurements, save them in the instrument's memory, and then download them later. Greetings from the U.S., Julia. I'm sorry, Kim, I don't quite understand your question. If you could try to clarify for me, hopefully I can answer. You will all be sent this presentation in PDF format over the next few days. What is the recommended method for cleaning the standard if it gets dirty? Really, the recommended method is just to breathe on it a little bit, just to create a little bit of moisture, and then wipe it with a lint-free wipe. Every gloss meter actually includes a lint-free wipe, but you can also use just a Chem wipe to clean it. If it gets especially dirty, you can also clean it with isopropyl alcohol. Just make sure it doesn't leave a residue, as it sometimes can. But definitely no acetone or anything harsh like that. That can affect, it can etch the glass and affect the gloss value. Are you guys working on a gloss color meter that's capable of accurately reading metallic coatings? So our gloss meters are capable of measuring metallic coatings. I believe you're talking about coatings that have metallic pigments in them, like aluminum flake, which is often what car finishes have. And we do have a color meter just for that purpose. It's called the Bic Mac I. It is a multi-angle color meter that we recommend measuring those surfaces with multi-angle meters, because with metallic coatings, with coatings with metallic pigments in them, you can get what's called light-dark flop, meaning the apparent lightness of the surface will change depending on the viewing angle. And so it's necessary to measure such surfaces at a number of different angles to make sure that the color is consistent all the way around, no matter the viewing angle, instead of just at one angle. If you're asking whether we have a combination color meter and gloss meter for metallic coatings, we do not. The Bic Mac I does not have a built-in gloss meter with it. When you're doing in the software average of 3 readings, can you set up a tolerance and warning between those 3 readings? So it will tell you whether each of those individual readings is in or out of tolerance during measurement. Once you finish the measurements, it does not retain the individual readings, so you'll only get that indication for the average of the measurements. Any specific precaution for measuring gloss of transparent coatings on concrete surface? None really. Again, it is good to standardize a direction because concrete can often have directionality to it. So make sure that you're measuring in the same direction each time. But of course, in this case, we're talking about a transparent material where the concrete would be the backing. So there's no backing necessary to apply to it. You would just use the concrete. Does the Spectra 2 Guide D8 able to do gloss measurements? Yes, it can. The Spectra 2 Guide is one of our newest portable spectrophotometers, and it also has a built-in 60-degree gloss meter. So yes, it does color and gloss, and you can expect the same excellent technical performance out of the built-in gloss meter with that instrument as you can out of our standalone microgloss instruments. Does auto-calibration negate the need for periodic outside calibration by BIC? No, it does not. First of all, let me clarify, when you turn the meter on and it does that auto-diagnosis, it is only checking the standard to make sure it's measuring it correctly. It is not actually performing a calibration. So you still manually need to go into the menu and select calibration every once in a while to calibrate the meter to that gloss standard in the holder. We recommend doing it maybe every month or so. The optics are very, very stable. We use very stable LED technology, which we actually guarantee for 10 years. We guarantee the light source for 10 years on all of our instruments. But no, that calibration done in the holder, that is only a 1-point calibration, so you're only calibrating it to a single gloss tile, whereas when you send it to us for calibration, we're calibrating it on something like 26 different gloss tiles to make sure that the meter is accurate across the entire range of gloss and not just one. Is 60-degree gloss measurement from the Spectra 2 guide comparable to S family microgloss? Yes, that is the case. The gloss meter built into the Spectra 2 guide does have that better precision, better measurement uncertainty in that low gloss range, just like the S family of microgloss meters. The software can indicate if the readings are not different or only the average. So again, once you finish averaging readings for a sample, it only retains the average, but it does also retain statistics. So it will tell you, it will give you the standard deviation, it will give you the min, the max. So in a sense, yes, it will differentiate between the individual readings with statistics. Someone is asking about price range. So that's a difficult question to answer because, of course, we do sell these meters internationally. So I don't want to speak out of turn here. I would encourage you to contact your local rep for pricing on these meters. Or you can go to our website. I believe your local pricing should be available on our website as well. You mentioned metallic finishes. Would fluorescent colors follow the same level of extra checks to ensure accuracy? So fluorescent colors do not need to be measured at multiple angles if that's what you're asking, but it is important that you have a meter that can accurately measure fluorescent colors, which not all meters can. Our Spectra 2 guide instrument actually not only is it actually the most accurate meter on the market specifically for measuring fluorescent colors, but it can actually separately quantify the fluorescence in your color and tell you how much of the color is due to fluorescent pigments and how much the color will change once those fluorescent pigments fade. So if you want to learn more about that instrument, I would encourage you to attend one of our web seminars on the Spectra 2 guide instrument. We might, I'm not certain that a web seminar recording might still be available on our website, so look for it there. If not, of course, you can reach out to us directly and I can help you understand that directly as well. Kim, I'm not certain what a G gloss measurement is either. They might just be referring to gloss units. It's hard to say, but if you'd like to reach out to me directly, we can maybe try to figure it out together. Okay, it looks like that is the end of our questions, and it looks like I've gone a few minutes over on time, so I will go ahead and end today's web seminar. I want to thank you all sincerely for coming. I hope it was beneficial to all of you, and I hope you all have a great rest of your day, rest of your week, and weekend.